welcome to the continuation of our online physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exams. Now for today's presentation, we shall be considering the concept of work done and energy in a stressed wire. I am Bangbade AA. Before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to calculate the work done on a stressed wire. They should also be able to calculate the energy stored in a stressed wire. They are also expected to be able to calculate the elastic potential energy. And lastly, they should be able to solve relevant UTM questions relating to work done and energy in a stressed wire. Now, before we proceed to the real calculation, we need to remind ourselves of the relevant formula relating to the concept of work done and energy as discussed in our video 14. So I urge my listeners to please refer to our video 14 for the necessary foundation on this particular concept. Now, we shall be discussing the relevant one to the concept of work done and energy. There we describe the work done as the product of the average force and its tension. We also derive the formula for work done to be half Fe. Alternatively, our work done can be calculated using work done equals half Ke squared. K here represents the force constant. K here represents the force constant in Newton per meter. E represents the extension in meter. F represents the force in Newton. And lastly, we talk about the elastic potential energy, which can be calculated using half Ke squared. So the summary is that for our work done and energy is either we use half Fe or half Ke squared to find it. Now, having understood the formula for the concept of work done and energy on a stressed wire, the next thing we shall be considering will be the sample questions from the UTME. And the first question we shall be considering comes from 1994, number 14. And the question goes thus. A spring of length 25 cm is extended to 30 cm by a load of 150 Newton attached to one of its ends. What is the energy stored in the spring? So you have option A to be 3750 joule. Option B is 2500 joule. Option C is 3.75 joule, while option D is 2.50 joule. Now on to the solution. As usual, the first thing to write out is the given parameters, and from the question we're given the force F to be 150 Newton. Then we are also given the new length to be 30 cm, while the original length is 25 cm. From this, we can calculate our extension you can recall, in our video 40, we said extension is the difference between new length and the natural length of an elastic material. So in this case, our extension E will be L1 minus L0, which is equal to 30 centimeter minus 25 centimeter, and of course that will give us 5 centimeter. But we need to convert it to meter before we can use it in further calculation. And since 100 centimeter equals 1 meter, we can convert 5 centimeter to meter by dividing it by 100, and that will give us 0.05 meter. Now that means our extension is now 0.05 meter. Then we can proceed to substitution in the formula using the formula energy E equals half Fe. So we substitute, E will be half into F, which is now 150 Newton, then times E, which is 0.05 meter. So half of 150 is 75, then times 0.05 will give us 3.75 joule, making option C the correct answer for this particular question. Now the next question we shall be considering comes from 1995, number 14, and the question goes thus: the energy contained in a wire when it is extended by 0.02 meter by a force of 500 Newton is dash. Then we're given the option A to be 5 joule, option B is 10 joule, option C is 10 raised to power 3 joule, while option D is 10 raised to power 4 joule. Now on to solution. As usual, the first thing to write out is the given parameters, and from the question we're given the force to be 500 Newton and extension E to be 0.02 meter. Now we should recall that energy E equals half Fe. Then when we substitute for this, our energy will be equal to half into F, which is now 500 Newton, times E, which is 0.02 meter. Then half of 500 will be 250, then times our E, which is 0.02 meter, will give us 5 joule, making option A the correct answer for this particular question. Now the next question we shall be considering comes from 2007, number 15, and the question says a spring of force constant 500 Newton per meter is compressed such that its length shortens by 5 centimeter. The energy stored in the string is dash. We're given option A to be 0.625 joule, option B to be 6.250 joule, option C is 62.500 joule, while option D is 625.00 joule. Now on to solution. The first step is to write out the given parameters, and from the question we are given the first constant K to be 500 Newton per meter. We are also given the extension, but from the question they said that the string is compressed such that its length shortened by 5 centimeter. That means the extension is 5 centimeter. But we have to convert it to meter before we can use it in further calculation. And since 100 centimeter is equal to 1 meter, we divide this 5 centimeter by 100, and that will give us 0.05 meter. Now let's proceed to the substitution. We are to record that the energy E equals half k E square, and if we substitute for this, our E will give us half into k, which is 500 Newton per meter, then into E square, which is 0.05 meter square. Now that will lead us to E equals half into 500 Newton per meter can be expressed as 5 times 10 raised to power 2 when you take it to standard form, then times 0.05 can be expressed as 5 times 10 raised to power minus 2. But because of the square we are having here, 5 times 10 raised to power minus 2 will now lead us to 25 times 10 raised to power minus 4. I mean 5 square is 25, then 10 raised to power minus 2 square will give us 10 raised to power minus 4. Now we can readjust by multiplying the real digits here, and that will give us E equals half into 5 times 25 will give us 125, then times 10 raised to power 2 minus 4. Half of 125 is 62.5, then times 10 raised to power 2 minus 4 will give us 10 raised to power minus 2. So this means 62.5 divided by 100, and that will lead us to 0.625 joule, making option A the correct answer for this particular question. Now the next question we shall be considering comes from 2009, number 16, and the question goes thus: if a load of mass 10 Newton stretches a cord by 1.2 centimeter, what is the total work done? We are given option A here to be 6.0 times 10 raised to power minus 2 joule, option B to be 7.6 times 10 raised to power minus 2 joule, option C is 1.8 times 10 raised to power minus 2 joule, while option D is 6.6 times 10 raised to power minus 2 joule. Now on to solution. The first step is to write out the given parameters, and from the question we are given the force, which is 10 Newton. They said a load of mass 10 Newton. That means the force here is 10 Newton. Then we are given the extension. They said a load of mass 10 Newton stretches a cord by, that means the extension is 1.2 centimeter. Similarly, in this case, we convert 1.2 centimeter to meter by dividing it by 100, and that can give us 1.2 times 10 raised to power minus 2 meter. Then we can proceed to substitution for the formula, and therefore using energy E equals half Fe, that will give us half into F now, which is 10 Newton, then times E, which is 1.2 times 10 raised to power minus 2. So half of 10 is 5, then times 1.2 times 10 raised to power minus 2. 5 times 1.2 will give us 6.0. Then the final answer will now be 6.0 times 10 raised to power minus 2 joule, making option A the correct answer for this particular question. Now on to practice question from the UTME, and the question here comes from 2010, number 11, and the question goes thus: if a wire 30 centimeter long is extended to 30.5 centimeter by a force of 300 Newton, find the strain energy of the wire. So you are given option A to be 7.5 joule, 50 joule. Option B to be 750.00 joule. Option C to be 75.00 joule. Option D to be 0.75 joule. The hint here, you have to record that energy equals half Fe and the extension E equals L1 minus L0. That is the change in new length and the original length. Expected answer here is 0.75 joule. That is option D. Now our next video will be on hydrostatics with sample questions and solution from the UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lecture relating to UTME, especially physics. Thank you.